Hi guys, Shouvik and welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have type of triangles. This problem is stacked as an easy, and I also feel so it's super easy. So if you know like basic of triangles, then you can solve it like this way. Yeah. So on these problems, you are given a zero index integer array nums of size 3, which can form the sides of a triangle. A triangle is called equilaterals if it has all the sides equal length. A triangle is isoscalic if it has exactly two sides of equal length. A triangle is scaling if all its sides are different length. Return a string represents the type of triangles that can be formed or none if it cannot form a triangle. So what they have given three length of the three edges of the triangles, and we have to say if it is a equilateral, scaling, or isoscalics, or it's altogether not a triangles that we have to return. So in this example you can see 3 3 3 it's an equilateral triangle, so all are equal lengths edges. 3 4 5 it's scalings, like none of the edges are equal. So now if we can go quickly to our OneNote, so there are a couple of cases actually that I want to discuss. What it is, space days case, it's working. Let me connect to the space days once very quickly. It's on, and on my device I can connect to it, right? Yes. So there are cases like the first case is very simple. So if I name them kind of like what happens. Okay, it's on selected. I selected the pane. Yes. So what actually the things we have at. So I have to select from here on. I have to select, done. Selection's done. Can I write? Yes. So let's consider ABC are the edges of the triangles. ABC are the edges of the triangles, right? So at the very naive, like equilateral case is I think very simple. So when all of them are same, so what is the case for them? I'm writing the pseudocode only. So if A equals to B and B equals to C and C equals to A, like kind of all are same, then so you are at very good state to return a equilateral triangles, like it is like all are same, so all edges are same. But if that is not, so there is a case. Remember, there is a case of none. If it is altogether form a triangles or not. What is the case for that? If you done mathematics on like class 3 to 4 standard, I guess, when it's got started to us. So a triangle is going to be valid. So if I am considering the edge lengths are kind of sorted. C is the highest length edge, B is the second highest, and A is the smallest length edge. So my sum of the two smallest length should be greater than, not greater than equals to, should be greater than the largest length edge. So these conditions should valid all the times. Then on that case we can consider it as a triangle. Only if these conditions is valid. A plus B, the sum of the smallest edge is greater than the sum of the, the largest length edge is going to be the sum of the two smallest length edge is bound to be greater all the times to the length of the largest length edge. So then only we can consider it is a valid triangle. So on else case, so this case is very straightforward for us. So now what is the second case then? On else there are a couple of cases. Either they are valid. So what is the validity case? I am considering that the nums they have given to us is sorted, or in safer side we can do a nums.sort we can do. So although it is a 3 length, so the time complexity is very naive, like very nothing here. So nums.sort we can do. So then on that case we know nums0 is the smallest, nums1 is the just greater than of the smallest one, and nums2 is the largest out of them. So on the else case, what is the conditions? We have couple of cases. If my num0, that is the smallest 2, plus my nums1, that is the second smallest one, bound to be greater than my nums of 2, should be greater than my nums of 2. If that is the case, right, then we have to check further. Then what we can check? If num0 is equals to my nums1, or either of them is equal. If nums0 is equals to my nums2, or what is the case? or nums1 is going to be equals to my nums2. If any of the case is going to be valid, no, if any of the case is going to be valid, then can I say like this is a valid, then can I say this is a isosceles one? Yes, then on that case you can return an isosceles, like two sides are identical. Else if that is not the case, you can blindly return a scaling, you can blindly return some scaling things. It is a scaling. And if that is not, like what is the case, cases we have written? If nums of 0 plus nums of 1 is not greater than equals to, if this case is invalid, then we are going to jump on the else block. Then on else block we can return, tell me guys, on this else block we can return a none, on the else block. So there is a lag of this one node, so that's the reason it's going to be like overrated. But yeah, like we will definitely do a code iterations now. We got all the cases forward. Yeah, so we have done nums.sort so that the elements are in sorted. So now we have assigned ABC to nums0, nums1 and nums2. If we are sure that all are same, then return equilateral. If A plus B is greater than C, so that is the case, it is going to be a valid triangles altogether. If that is so, then either AB same, either BC same, or either AC same, then we can return isosceles. Else we can return scaling. Else if this conditions like altogether triangle validity is going to be false, then we can return none. As simple as that. Yes guys, so the code is as simple as that. And on time complexity, I don't think we are using any time altogether. That is a constant time only. So on time complexity, that is this nums.sort may be going to take some time, but it is of length 3 in all the cases, right? So nums length is all the cases is 3 only. So it is kind of 3 log 3, and sorry, it is kind of 3 log 3, and base is going to be log 3 base 2. So how much it is? Log 3 base 2, log base 2. Can see where I move 3. So it is kind of 1.585. Cal C open first. 1.585 multiply by 3. So it is 4.755. Like I can consider 5 in whole numbers altogether. So where we are? Yes. So the time complexity is kind of big of 5. You can write directly, right? So 4.785 something. So we can write kind of big of 5 at very worst case. But at very worst case it's only become 4.785. Like all the cases only. Because nums length is 3 for all the cases, so big of 5 you can consider. And on space complexity 2, you see guys, we are using any space altogether. Nope. All are variables. So on space complexity, it's bound to be like constant. It's of big of 1 for sure. There is no chance we are using any space. Yeah, so you can see also like my submissions is altogether 100% faster than all the submissions we did over the Leetcode, and on analysis also like it's a kind of constant. On time complexity also it's showing big of 1 only, and on space also like it's beats 99.5% of all the submissions over the Leetcode. So on memory also like we are at big of 1 only. So our time and space both are like you can tell like big of 1, but that is the exact, like try to like explain on your interview like that much clarity. So then it is clear, like creating a different bar from other candidates, no? So that's the reasons I am explaining like this way. So try to explicitly mention these things, but yeah, we all know it's constant time, constant space, but explicitly mention these things. Yes guys, so this all about this particular code altogether and this particular problems altogether. And if you guys are able to understand, so I guess you guys are already doing, so please do subscribe to the channel. Please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills, and turn on the notifications so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.